Hello again, Algebra 1 students. Congratulations on making to Tier 3. We're in Unit 3, Week 1, Discrete Function Syllabus. We are on Tier 3, Lesson 1, multi-step functions with fx notation. So let's check off our booklet. So here we are with writing multi-step functions with fx notation. So I want to do this first one, which is addition as our operator. And I'm just going to pick some points. And again, I always like to go easy. So 1, 2, 3. Keep it simple. That's my motto. All right. So what we're going to do is we're going to evaluate f of x at these values. So how we write that in f of x notation is we're going to evaluate f at 1. We're going to evaluate f at 2. And we're going to evaluate f at 3. And all that means is anywhere that you see an x, just like we replaced the x here in the function notation, you're going to replace it in the actual expression of the function for each one of these. So I'm going to erase those out. When we do f evaluated at 1, we're going to take the 2, and where we see x, we're going to put a 1 plus 4. And then f evaluated at 2, we're going to take a 2, and where we see the x, we're going to put the 2 plus 4. And where we see f evaluated at 3, we're going to do 2. And where we see the x is where we'll put the 3 plus 4. So now we can solve these. 2 times 1 is 2 plus 4 is 6. So when we plug 1 into f of x, we get an output of 6. 2 times 2 is 4 plus 4 is 8. So when we plug 2 into f of x, we get an output of 8. And f evaluated at 3 gives us 2 times 3, which is 6, plus 4, which is 10. So if we plug 3 into f of x, we get an output of 10. Let's go down and look at a subtraction function. Again, I like to be super simple, but notice that this is a fraction. So whenever I am working with a fraction and functions, I want to get rid of the fractions because I'm sure you guys feel the same way about fractions that I feel, that they're just messy to work with. So how I get rid of fractions is I want to pick numbers that are multiples of the denominator. That's what I'm pointing at right here, the denominator, the bottom number. I want to pick multiples of that. Well, the first multiple of 2 is 2. And then the next multiple of 2 is 2 times 2, which would be 4. And then the next multiple of 2 is 2 times 3, which would be 6. So these are all multiples of 2, and by inputting those, I'm going to be able to get rid of my fraction when I solve for it. So again, wherever I see the x, those values, so we're going to evaluate g at 2, we're going to evaluate g at 4, we're going to evaluate g at 6. So let's do our first one. So g at 2, we have negative 1/2 times 2 now, because the 2 is going in for the x, minus 1. Again, we have negative 1/2 times 4 now, because the 4 is going in where the x was, minus 1. And then last here we have negative 1/2 times 6 now, minus 1, because the 6 goes in where the x is. So now let's solve these and get our outputs. Well, negative 1/2 times 2, well, what's half of 2? 1, but it's a negative. So negative 1 minus 1 is negative 2. So when we put 2 in, we get negative 2 out. Half of 4 is 2, but it's negative. So negative 1/2 times 4 is negative 2, minus 1 is negative 3. So when we put 4 in, we get negative 3 out. And then 6, half of 6 is 3, but times a negative is a negative 3. So negative 3 minus 1 equals negative 4. So when we put in 6, we get a negative 4 out. And that is our subtraction function with a fraction that makes it a little bit more challenging. Let's go down here to this h of x, because this is a really cool one. This is an exponential function, and I want to do something really cool with this. I'm going to teach you some different things too on this one. So with this one, we're going to put in 0, we're going to put in 1, and we're going to put in 2. We're going to evaluate h at 0, we're going to evaluate h at 1, and we're going to evaluate h at 2. But notice the x is an exponent here, which doesn't matter. We still just plug the value that we're evaluating at, 0, 1, and 2, in for where we see the x. So here we have h evaluated at 0 is simply just 2 raised to the 0 power, where the x goes, plus 5. Here we're going to have 2 raised to the first power, plus 5. Here we're going to have 2 squared plus 5. And now we just have to solve the expressions. 2 to the 0 power, anything to the 0 power, anything is always just 1. So 2 to the 0 power is 1, plus 5 is 6. So our output here is 6. 2 to the first power is 2, because anything to the first power is just itself. So 2 to the first power is 2, plus 5 is 7. And then lastly, 2 to the second power is just 2 squared, which we know is 4, plus 5, which is 9. That's how you evaluate functions at given values. Let's look at this. So we want to find f evaluated at 0. Here's our f. Let's come up here and evaluate it real quick at 0. So f evaluated at 0 is equal to 2 times 0 plus 4, which equals, well, 2 times 0 is 0, and plus 4 is just 4. So f evaluated at 0 is just 4. So 4. But we have this little operation in between, so all that means is we're going to add it. Now let's go look and see what g evaluated at 2 is. Hey, we already did g evaluated at 2. It's right here. So g evaluated at 2 just gives us negative 2. If we wanted to add f of 0 plus g of 2, we would get 4 plus negative 2, which gives us just 2. Now let's go look at h of 3 minus g of 4. Well, what's kind of cool is we already did g of 4 again. It's right here. So we know that g of 4 is going to come out and be negative 3, so it's going to be minus negative 3. But we haven't done h of 3, so let's just do it real quick. H evaluated at 3 is going to equal 2 raised to the third power plus 5. Well, 2 raised to the third power is the same thing as saying 2 times 2 times 2 plus 5. Well, 2 times 2 is 4, times 2 is 8, so that gives me 8 plus 5, which gives me 13. So my h evaluated at 3 gives me 13 minus negative 3. Well, remember from Unit 1, anytime you subtract the negative, those both just become positive. So it's 13 plus 3 gives me 16 when we do h of 3 minus g of 4. So basically, whenever you're evaluating a function at a given value, you're just taking that value and plugging it in for the x value, just like we did with g of x, just like we did with h of x, and just like we did with f of x. Good luck on your problem sets.